Okay, we are moving on to our second unit in our 8th grade year, which is solving equations. Our learning target today, you can solve one-step equations with multiple operations. So some vocab words aligned with an algebra unit is inverse. Inverse operation undoes an original operation. Now this is not a good way to think of it, but it's definitely a way I do. I think inverse as what is the opposite. Because when you do the opposite, it usually undoes. Think about science, a proton and an electron, right? So a proton, if they combine with an electron, they just cancel out, don't they? And you like a neutral, there's no charge to it. I think so. I think solving equations means you get the variable alone. So if I say solve this, it means you're going to be left with x equals something or y equals something. Solve means get variable by itself. Figure out what the variable is. In balance, balance just means with algebra you have to maintain balance in an equation. It says what you do on one side, you must do on the other. So there's two sides to an equation. And there's the left side, like let's make it 2x plus 9 equals 5. There's a left side and there's a right side. So whatever you do to the left side, you have to do to the right side. That's all it means. And now, let's just talk about the different inverse operations. Again, inverse means opposite. How do you undo it? How do you cancel it out? So, here's the four main operations. Add, subtract, multiply, divide. What's the opposite of add?
Subtract.
Yes. To undo addition, you need to subtract. What's the opposite of subtract? Add. What's the inverse of multiply?
Divide.
What's the inverse of divide? Yes. So if you know inverses, like I heard you quickly go through them, then you know how to solve an equation. The only thing that gets tricky is I usually add integers in there and then it gets a little messed up. But the foundation of algebra is this box. Being able to identify what inverse operation you would need to use. All right, now we're just going to practice. We're going to solve equations. I don't know if I have the steps here. Some of you like steps, some of you don't care if you have steps. You just want to do it. I'm going to first tell you the steps and then I'll just model it through actually doing it. The first thing I do is determine what inverse operation I'm going to do. So I say, okay, in order to get the variable alone, am I going to add, subtract, multiply, or divide? And then we're going to do that operation on both sides. Okay, so the first one, I always say it aloud. X minus 3 equals 7. How do you move minus 3? Yeah, plus 3. I need to do it to both sides. X equals 10. Now my variable's alone because the 3's canceled out. Okay, now this is where the rigor is going to get increased. X plus 4. How do you move plus 4?
Subtract.
Okay, subtract. Now watch. Whoops. Watch how it gets weird. Minus 4, minus 4. X cancels. Now this is where you have to be so careful. It's not 5. It's not negative 5. You plus a negative here. They're the same sign, so you add them. So it would be negative 13. Is that what you're going to say? Yeah. Now I kids always struggle with this one. They usually write -5. So I want to think of a way, how do you know right away you could add those up? Maybe the 2, remember 2 negatives turn to plus? So you could think, oh, a negative and a negative, I'll add it and make it negative. Maybe you could think of it that way. Or you could plus a negative. Just find a way that works for you and try not to let yourself fall into that common mistake. 5 plus x equals 7. How do I move the 5, Gatlin? Right, because this is a positive 5. To move the positive, I would subtract 5 to both sides. X is equal to 2. X minus 5 equals -11. The only time that takes away from the easiness is when we have those darn integers. So now I plus 5, plus 5. X equals, do I add or subtract these two? Subtract, because they're different signs. So since it's negative with a positive, you subtract, and I have more negatives. Okay, y plus 9 equals -10. Subtract 9. Y equals, now am I going to add or subtract these? Add, make it negative. I add because they're like that same sign. So same sign, you add it up, keep it negative. Okay, plus 8 on the next one, plus 8. M equals, do I add or subtract these? And is it positive or negative? Positive. Because I have 8 positive, 4 negative. So again, the rigor level here comes from integers. You need to know the prerequisite for this kind of stuff. You need to know, when do you add integers, when do you subtract? That's what you really got to know, and that gets hard. You add them when they're the same sign, you subtract if they're different. See, different signs I subtract. Same I add. Different subtract. Different subtract. Same add. Same add. So it's really, it's tricky. It takes practice. Okay, next concept is just more examples. I want you to go through these examples. Okay, moving on. So we did adding and subtracting. Now we're moving on to multiplying and dividing. Multiplying and dividing. Okay, 3x equals 33. This means 3 times x. How do I move times?
Divide.
So this is how we show division. Not with the divide symbol, with a fraction bar. That cancels the 3 out and you get x equals 11. You see? The next one, -2 times x is 20. How do I move times? So I'm dividing by -2. That cancels out and I get x equals -10. So again, we're assuming that you have a strong foundation of integer knowledge. Here you need to know when it's going to be positive and negative. X over, what does over mean? Divide. So how do I move divide? So I'm going to times both sides by 5. That cancels the 5 out. X equals -45. Oh, tricky. This next one is tricky. -x over 4. How do you move over 4? Multiply by 4. And I get 48 equals -x. This is really -1, isn't it?
Yeah.
To move -1, you divide by -1, and you get -48 equals x.
That's what I got.
think that's about where I want to stop today.